Hello boys and girls, and welcome back. Today we are going to be talking about a different way to solve systems of equations. So today we are going to be talking about solving systems of equations by elimination method. Alright, so our objective for today is I'll be able to solve a system of equations with the elimination method. Alright, so elimination method is adding or subtracting the two equations to eliminate one of the variables, or to temporarily eliminate the variables so you can solve for one in order to solve for the other. So let's take a look at what that means exactly. Alright, so this looks like a lot of information, so please don't let it overwhelm you. I wanted to put it all in one slide so then I could show you the examples step by step with the written steps as well. I think last time that worked better for us. So step one, line up the variables so they are underneath each other. So look at our example right here. It's 8 minus 2y is equal to 14, and x minus 2y is equal to 14, and x plus 3y is equal to 9. Well, as you can see, the x's are lined up underneath each other, and the y's are lined up underneath each other, and the constants are lined up underneath each other. That's what I mean by line up the variables so they are underneath each other. So if we have a system of equations where one is in standard form and one is in slope-intercept form, you're going to need to manipulate one of the equations or switch it around so they are both in the same form, so then we can line up the variables. All right, step two, determine whether x or y will be easier to eliminate. And just a note, in order to eliminate that variable, the coefficients must be the same number. So let's take a look at this equation. We have x minus 2y is equal to 14 and x plus 3y is equal to 9. Well, right away we see that in both equations our x variable has the same coefficient. They both have a coefficient of 1. So in this case, the x variable is what we're going to eliminate. All right, step 3, in order to eliminate the variable, the coefficients must be opposite, negatives of each other. To make this happen, you might need to multiply the entire equation by -1. So right now, in both of our equations, x minus 2y is equal to 14 and x plus 3y is equal to 9, both of the x's are positive. Well, we need to make it so one of the x's is negative in order to make an elimination. So in order to do that, we simply need to choose an equation. It doesn't matter which one, so I'm just going to pick the bottom one. Really, it's random, so I just pick the bottom. Okay, and we're going to multiply the entire equation by -1. And what that's going to do is going to change this x into a negative x. Alright, so I'm going to rewrite the top equation just the same, just so we can have them underneath each other still. And then we're going to multiply all of the terms by -1. So -1 times x is negative x. Okay, -1 times positive 3 is x, or 3y is a minus 3y, equals, and then don't forget about both sides of the equation, -1 times 9 is -9. We just essentially switch the signs of all of the terms. Step 5, find the value, we skipped one. Step 4, add the equations. So what we're going to do is we're going to add these two equations. And essentially it's going to eliminate one of these variables. So x plus -x. So, or you can read it as 1 plus -1. Well, that equals 0. So we just eliminated the x. Right? So now we have -2 plus -3. And that is -5y is equal to, and then we have 14 plus -9. Well, 14 plus -9 is, let me think, it is -5. Okay? Or, yeah, +5, my bad. 14 minus 9 is +5 because you take the sign of the bigger number. Alright, so now we need to solve for y. We have to divide both sides by -5. And then we get y is equal to -1. Okay? Y is equal to -1 is what we found by this elimination method. Alright, step 5, we find the value of the other variable by substituting the value we just found into the original equation. So just like we did with the other method, with the substitution method, once you find one variable, you have to still find the other one by substituting it in. So it doesn't matter what equation we pick, we're just going to substitute y in over here. Alright, so it really doesn't matter. I'm just going to pick the second equation. You could have picked the first. It'll be exactly the same. So we have x plus 3 times -1 is equal to 9. Alright, so x 3 times negative 1 is negative 3 is equal to 9. We add 3 to both sides to isolate the variable, so we have x is equal to 12. Okay? So we have x is equal to 12, y is equal to negative 1. So our answer is 12, negative 1. Alright, so to check our work in this case, we simply plug both the x and the y back into both original equations. So for the first equation, it would be 12 minus 2 times negative 1 is equal to 14. And if both sides are equal, we know that we did something right. And since it's a system of equation, we need to check both answers. And if you take a second, pause the video, and check both answers, you will find that we did it correctly and that we will be getting the correct answer for both. All right, let's take a look at this one. 3x plus y equals 1 and 2x plus 3y is equal to negative 11. Now this one's slightly different. It's the same concept, but the difference is, and I have the note up here, because the system doesn't already have a variable with the same coefficient in both equations, we need to multiply the entire equation by a number that will make the variable the same. And remember, we want the opposite. So let me tell you what I mean by that. So right now we have 3x plus y is equal to 1. And 2x plus 3y is equal to negative 11. Well, in the last example, we already had, we knew that we wanted to eliminate the x's because it was already a coefficient of 1 in both equations. In this example, in this system, we don't have that. So we need to look, and we need to ask ourselves, what can we multiply to get one variable the same? All right, so let's think. 2 and 3. Is there a number that we can easily multiply either one of them by to get them the same? One number? No, not so much. But we have 1y and 3y. There is a number that we can multiply the entire equation by to get them the same number. Okay, we can multiply it by 3. And the reason why we want to do that is because we want to get this 3y to be a negative 3y. So if we multiply the whole equation by negative 3, we will have our equation set up the way that we want it. All right, so let's go ahead and do that. We want to multiply this entire equation by negative 3. And once again, the reason why we want to do that is because we want to get one variable in each equation of the coefficients to be the same. All right, so when we multiply negative 3 times positive 3, we get negative 9x. Negative 3 times y is negative 3y, or minus 3y, is equal to negative 3 times 1 is negative 3. And then I'm going to simply rewrite this equation so we can see it nicely underneath each other. All right, now we're going to add these equations. Okay, so we get negative 9 plus 7 is negative 7x. These cancel out because negative 3y plus positive 3y is 0 is equal to, we have negative 3 plus negative 11, which is negative 14. Okay, now we're going to divide both sides by negative 7. These cancel out. Negative 7 divided by 7 is equal to x. Negative 14 divided by negative 7 is equal to 2. So we just found that x is equal to 2. Now we need to substitute that 2 into one of the equations to get our y. So I'm just going to use the top equation. 3 times 2 plus y is equal to 1. Okay, well 3 times 2 is 6, so 6 plus y is equal to 1. Subtract both sides by 6, y is equal to negative 5. Alright, so our answer to our equation is 2 comma negative 5. Okay, so take a second and check our work. So pause the video, check the work, and make sure that this works for both equations, both of the original equations. Alright, so as you checked your work, you did find that this is true. So we did the math correctly. Alright, so now I want you to try solve this by elimination. So if you're having trouble at first, please go back and re-look at the examples, re-listen to how I did it, and that will help you, okay? And last but not least, you have any questions over what you just did, write them down so then I can answer them as I come around and check your work. So with that, thank you so much for actively listening and for being good students, and I will see you later. Bye-bye.